Okay, in our last video, we focused on the first quadrant of the unit circle. So we talked about all of these values in here. And hopefully after that last one, you could fill in all of these values, the degrees, the radians, and the coordinates of cosine and sine from memory if you needed to. Just a few important highlights from that video before we move on to the rest of the circle. First of all, these special points are not the only points on a unit circle. There are infinitely many little points all around the circle. They all have a degree measure, they all have a radian measure, and they all have xy coordinates that we could list as sine and cosine. If you typed in any of those, cosine of any degree, you're going to get the x coordinate of that point. So why are these points so special and lucky to be included whenever somebody talks about the unit circle? Well, that was my next review. These are the points that are made by our special right triangles. This one is a 30, 60, 90, where it is, I would call that a short triangle. It's more to the right than it is up. And then this is a 30, 60, 90. That's a tall one. It's more up than it is to the right. And then you have the 45, 45, 90, which we talked about in great detail. But those are special points because we can find the lengths of the legs, the cosine and sine, without a calculator. Those are our special points because they're special right triangles. All right, so what we need to do now is extend this process to where at the end of this one you could fill out a complete blank unit circle from memory or by figuring it out on the spot. It's less memorizing and more just reasoning, if you ask me personally. Okay, so let's start with degrees. The degrees I'm not so worried about because if you know a full circle is 360 degrees, you can pretty much, with a little bit of understanding, fill out the rest. Half the circle is 180, and a quarter of the circle is 90. And 3/4 of the circle is 270. And then all of these spots throughout the middle, these spots divide each quadrant into thirds, which means I can count by 30s if I move my way around those spots. Let me just omit for just a minute the 45 spots, the middle locations. Let's just focus on these other ones that are based on our 30, 60, 90 triangles. 30, 60, 90, 120, 150. I put that highlight in the wrong spot. Meant to highlight this middle one because I'm going to leave it out for now. 210, 240, 270 we already talked about, 300, 330. No biggie, I'm counting by 30s. You can handle that. And then if I go back through the middle and count by 45s, I'm going to get the rest of my degrees. So you can see this is a little bit of an easier process. See, if I go by 45s, I hit the 90, then I hit 135, then I hit 180. Between 210 and 240 is 225, and then 315. So not so concerned with your learning of the degrees, because this is an old idea. You've known that a circle is 360 for years, and you can cut that up with just some nice fractions. So let's talk radians. Let me just get rid of that. Remember, each location all around this unit circle has 3 bits of info, 4 if you consider the x and y coordinates different. Each one has a degree measure, a radian measure, a cosine and a sine, an x coordinate and a y coordinate. So if you consider the point one piece of information, this is 3 things for each point, 4 if you can consider them separate. So let's work our way around the circle talking about radians. The entire circle, because the circumference of a unit circle is 2 pi, the entire circle around the outside edge is 2 pi radians. So whatever units your radius is in, this circle is about 6.2 and change of that unit. So if this is a mile and you run around the entire outside, you've run 2 pi or a little bit over 6 miles total. Now we talked about the first quadrant, so you know that this is pi over 6, and this is pi over 4, this is pi over 3, and pi over 2. So like I just did a minute ago when I was counting my way around with 30 degrees, I'm going to kind of do the same thing with pi over 6s. This is kind of how I picture where these locations are in radians. Again, I'm going to leave out this first time around, these middle spots. These are all going to have 4 in the denominator. These are all the angles that ended in 5. 45, 135, 225, 315. Those are the only ones that end in 5. These are the ones that are going to have 4 in the denominators. And I'm just going to focus on the ones that cut each quadrant into thirds. So I could go, if I count by pi over 6s, then I can just simplify fractions. This is 2 pi over 6. This is 3 pi over 6. 4 pi over 6. 5 pi over 6. 6 pi over 6, and so on. Now these are not the way I'm going to leave them because some of these can be simplified. I'm just working my way up 1/6 pi at a time. So that was 10, 11, and then 2 pi, it could be 12 pi over 6. So when you're first learning this, you'll get more familiar with where these locations are, but if you work your way around counting 1 pi over 6, 2 pi over 6, 3 pi over 6, and then just simplify the fraction, you're going to get all your radian locations. 4 pi over 6 is 2 pi over 3. 5 pi over 6 cannot simplify. 6 pi over 6 is pi. 7 pi over 6 will not simplify. 8 pi over 6 is 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 is 5 pi over 3. 11 pi over 6 stays, and of course 12 pi over 6 is 2 pi. So now I don't really want to focus on these anymore. I'm not going to name them with these 1/6 fractions. I'm going to name them with the simplified versions, which now I have on the outside edge. So these are my radian locations at all the special points. So you can see some patterns. My 6s, my ones that have 6 on the bottom, are these shorter angles. Shorter meaning, I don't know if shorter is the proper word, but these are the ones closer to the x-axis. Those all have 6 on the bottom. The tall ones, closer to the y-axis, those all have 3 on the bottom. And then those ones that I left all have 4 on the bottom. So now I need to get to those. All right, so that's just, there's a lot of ways that it can make sense to you in your head how you know that 4 pi over 3 is right down here. All right, like I said, once you've done this quite a bit, you'll just know where that is by memory. But if you need to count it out by 6s, you can just get to 8 pi over 6 and then simplify it. So let's go back to those middle spots that are marked in red here. If I count up, sort of like I counted by 45s when I was talking about degrees, I'm just going to count up by 1 pi over 4, 2 pi over 4, and so on. So I get 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. You'll notice like the 90-degree mark, that is both an over 6 and an over 4 spot. But either way, it's going to simplify down to pi over 2. 3 pi over 6, 2 pi over 4. Both of those are pi over 2. My other spots, 3 pi over 4, I didn't even really need to write it and then simplify it because that's not going to simplify. 4 pi over 4 is pi. 5 pi over 4 just stays. And over here, 7 pi over 4 just stays. So all that junk in the middle is just my thought process, my counting and simplifying fractions to figure out that these are the radian names of all of the spots. Okay, so usually it all goes back to degrees. So if I say to you, where is 2 pi over 3? You could do the old-fashioned way and convert that into a degree measure by multiplying by 180 over pi, like we did with those book problems. You can count it out by 6s, you can count it out by pi over 3s, but you need to know starting now that pi over 3 is here. It's in the second quadrant, and it's that taller spot, the one up near the y-axis, not that lower one down near the x-axis. And you also need to know that that's 120 degrees. Okay, so that's the kind of thing we're working toward, and we'll get there with more practice. All right, so last on the agenda, sine and cosine of all of these spots. The other day, the other video, we figured out that this one was the square root of 3 over 2, comma 1/2, x, y, cosine, sine. These middle spots are the same distance left to right as they are up or down, both square root of 2 over 2. And then up here at 60 degrees, or pi over 3, it's over 1/2 up square root of 3 over 2. And then we had our kind of obvious ones, 1, 0, and 0, 1. And that's what we had with the first quadrant. So now, what's going to happen is we're just going to use symmetry, and we're going to extend this process to the rest of the quadrants. Okay? This point right here is a mirror image of this point over here. The only difference is that this has gone left instead of right. This thing is left square root of 3 over 2, so negative square root of 3 over 2, 1/2. All right? You can do that symmetry. The values, the distances are not going to change. You are always going to have 1/2s, square root of 3 over 2s, and square root of 2 over 2s. The only difference is what quadrant you're in determines which one is positive and which one's negative. Okay? This point right here is a mirror image of this point. So this is negative 1/2, positive square root of 3 over 2. The good thing about our middle spots, those 45s, those angles that end in 5, those radians that have a 4 in the denominator, I missed that one again, there it is. They're always going to have the exact same sine and cosine, just with the plus or minus for you to decide. So this is left negative square root of 2 over 2, up positive square root of 2 over 2. This one, they're both negative. Down here at 5 pi over 4, or let's see, 225. And then over here, it's positive negative. So that's those middle spots. On the other ones, on the 30s and 60s, those type spots, you have to decide which one's plus, which one's minus, if either. And you also have to decide which one's the long length and which one's the short length. Down here, it's 7 pi over 6. That's going to be left the long side of the triangle, square root of 3 over 2, negative since it's left. And it's down the short side of the triangle, negative 1/2. Everything's negative. Sine and cosine are both negative over here in the third quadrant. When I get down here to 240 degrees, now that one goes left the short side and down the long side. So that one is negative 1/2, negative square root of 3 over 2. All right, so use the symmetry. Don't feel like there's 100 different numbers you need to memorize. Use the symmetry. This one would be negative 1, 0 over here, 0, negative 1 down here. This next spot, short distance right, long distance down. 1/2, negative square root of 3 over 2. This last one, square root of 3 over 2, negative 1/2. All right, not memorizing, using symmetry and using patterns. All right, all of these spots, let's see, I'll mark them in green. These all have x coordinates of plus or minus 1/2. See how they're vertically aligned with each other? X coordinate 1/2, x coordinate negative 1/2, negative 1/2, positive 1/2. All right, so use that. It's probably going to be tricky for a little while, but it will not take long until you can start with this completely blank and end up with this final product. Degrees, radians, and coordinates, cosine, sine coordinates for every single point. All right, so let's call that. I was going to talk about the other trig functions, but I'm going to save that for another video. So as of today, What you need to be able to do is tell me all the spots in degrees and radians and the cosine of any of those angles and arcs. And that's going to do it. Young out.